Hello, everyone, and thank you for joining us for another episode of Decoding AI in Healthcare. Today, we have a wonderful couple of wonderful guests. Amit and I are delighted to welcome Dr. Bob Hoyt and David Patrishkoff, who are both going to talk to us about data science. So a little bit about Dr. Bob Hoyt, who is an internal medicine physician with a well-rounded background. He was in private practice for 15 years in Virginia when he returned to active duty, completing 3 years in the Army and 17 in the U.S. Navy, retiring at the rank of captain. In the last several years of active duty, he conducted research at the Navy Aerospace Medical Research Laboratory and the Robert E. Mitchell Center for Prisoner of War Studies located in Pensacola, Florida. He created and taught health informatics at the University of West Florida for 13 years. He is currently the editor and author of Health Informatics, a Practical Guide, which is in its 8th edition. And in 2014, he became board certified in clinical informatics, and in 2016 became a fellow of the American Medical Informatics Association. Since 2018, he has focused his attention primarily on data science as a new field that has impacted every domain, including medicine. He's passionate about teaching clinicians about important new trends in informatics and data science. This led to the creation of 2 new textbooks, Introduction to Biomedical Data Science and Data Preparation and Exploration. Information about these textbooks will be found in our links below. Dr. Hoyt is the honorary president of the Medical Intelligence Society, contributing monthly to the Data Science Tip of the Month virtual meetings. He's on the board and faculty for the American Board of Artificial Intelligence in Medicine board review course, and furthermore, a reviewer for multiple medical journals, including the new Intelligence-Based Medicine Journal. Also with us today is David Patrishkoff, a Lean Six Sigma Master Belt, Black Belt with C-level worldwide executive experiences with engineering, quality, and manufacturing responsibilities at a multi-billion-dollar revenue company. In 2001, he founded a consulting and training company, E3.business, where he has trained and consulted for organizations in over 60 different industries worldwide to resolve their mission-critical issues with innovative process improvement and data analysis techniques. In 2018, he added machine learning techniques to gain more insights into his research of large data sets, which included the fatality report analysis system for motor vehicle accidents in the US and the home health outcome assessment information set data for home health care patients in the US. He speaks regularly at international conferences about his research and other topics of interest. He's a contributing faculty at the Kettering University of Management in Flint, Michigan, and adjunct professor at the Dr. Kiran C. Patel Osteopathic School of Medicine in Fort Lauderdale, Florida, part of Nova Southeastern University. He is also adjunct at SUNY Polytech Institute in Utica, New York, and has incorporated Orange into some of the analytic classes he teaches at Nova and SUNY. He has trained, certified, and mentored many professionals in various topics, including over 3,000 professionals in Lean Six Sigma techniques. He and his company have also trained over 23,000 healthcare professionals in high reliability organizations plans to reduce medical errors in health systems. We are honored and privileged to welcome them both. Thank you so much for joining us.
So, a warm welcome to everyone, and a big welcome to Dr. Robert Hoyt and Dr. David. We've just heard their introduction. So, dear friends, we're back here with the 8th episode of the MedAI podcast, Decoding AI in Healthcare. And when we started this whole podcast, we started with a vision of taking the basics of artificial intelligence to all our peer groups and clinicians out there. And we are very happy to share with you that we've been able to reach out to most of you across 60 countries across the globe. And we continue to get fantastic responses and questions and comments coming in from our extensive peer groups across the world. So today we are actually going to have a very interesting session on data science. The question is, why data science? Why are we even talking about data? The whole architecture of artificial intelligence is based on data. And if you don't understand the science of data, then we are missing out a big chunk of the basics of artificial intelligence. Dr. Robert Hoyt, Dr. David, they have been a pioneer in training data scientists and, more importantly, training medical students and clinicians how to leverage the use of the basic knowledge of data science with as well as without the use of artificial intelligence tools. So, with this basic introduction to today's context, I would now request Deepu to go ahead with our panel discussion. And once again, a big welcome to both of you.
Thank you so much, Amit. Again, thank you, Bob and David. Well, let's start with the basics. Why is data science so important in today's world? And Bob, why don't you?
Okay, sure. Well, I don't think there's any mystery that we say data is the new oil. In healthcare, we say it's crude oil because the data is very messy in healthcare. All kinds of abbreviations, missing data, you name it. But nonetheless, we want to be fact-based. Even when you look at sports, they rely heavily on statistics. Well, so does every other industry. And healthcare is a little late coming to that conclusion, I might add. But part of that's because we don't share data. We've got HIPAA concerns, but I think we're waking up. I've often remarked that I found it interesting that evidence-based medicine doesn't talk about data, which is really strange. Evidence-based medicine talks about the end product, the study. Was it a randomized controlled trial, a systematic review, or was it a meta-analysis? They never go back to the beginning and say, but was the data flawed? And so this is kind of why we think that data science, and let's just say data, is pivotal to everything we do. And it gets people ready for AI. If you don't have data prepared, curated is a word some people use, I say jokingly, janitorial work with your data. If you don't get it ready for modeling with AI or whatever you're using, could be logistic regression, then it's garbage in, get garbage out. So I consider data to be the centerpiece of not just data science, but artificial intelligence as well. And I'll turn the floor over to David for his comments.
David, yeah, what else do you have to add to that?
You know, I've been, as you mentioned earlier in my introduction, I've been involved very heavily in the Lean Six Sigma community. And, you know, they've applied statistics to real life problem solving. And, you know, 30 years ago, when that community started, it was all based on, you know, we don't care about anybody's opinions. We want to see your data. And without your data, you're not even allowed to have an opinion. So, you know, I came from, you know, very deep problem solving background with that type of mindset. And obviously that flows 100% into, you know, what everybody's trying to do and what Bob and I are especially trying to do nowadays with, you know, machine learning and AI. You know, without that foundation, good data and data that you could criticize if it's really good and really usable, you really have nothing.
Right. That's absolutely right. Amit.
I mean, I completely echo with what Robert said. Data is the new oil, and you know, we are evolving from the domain of evidence-based medicine to a era of data-driven, intelligence-based medicine. So, with that context, data is important, but there are a lot of challenges. So, my question to Robert and David will be like, what are the biggest challenges that a data scientist faces in today's world? Not just a data scientist, I would even say, what are the challenges that a clinician or a researcher would face in terms of data science?
Okay, well, I'll start off and just say there are multiple challenges. One of them is we have been very programming centric, which is easy to understand. Statisticians tend to like R, computer scientists like Python, but the point is that's the starting point. And that's fine if you're in that very small group of data scientists or computer scientists that's in a master's program. But that doesn't include the average data analyst at your local hospital who probably can do some descriptive statistics, and that's probably the focus of their analysis, in other words. And I know plenty of statisticians who have not graduated to machine learning or AI. They're stuck doing, you know, inference and sampling and all of that. So it's a barrier. There's several barriers. One of them is we need more people to be able to teach data science. I think that's going to be a little bit of an obstacle. That's why, again, we're trying to find programming software that'll do all the same thing, and that way we have more students and then more faculty. Also, I might add that there is no federal mandate for data science or AI right now, whereas think about the HITECH Act in the United States. As a result of that, we had electronic health records implemented, but there was billions of dollars for education. That same impetus or incentive does not exist for data science or AI, but that allowed more faculty to be trained. In fact, a lot of the informatics professors, by the way, if you go back 10 or 15 years ago, they were biology faculty. They were just told, you need to stand up a health informatics department. Well, I think the same thing may happen with data science, but it takes momentum. There, as we well know, if you look at AI maturity, you have places like Stanford. I'm talking just about the United States. Stanford, the Mayo Clinic, MIT, they're all into AI totally, multiple departments. Then you go to other medical schools and there's zero informatics, zero data science, zero AI. So there's a big disparity among the programs. And right now, I will say, and then I'll turn the floor over to David, that industry is outstripping academia big time right now. In other words, they're making developments right and left in the field of AI, and academia can't keep up.
Right. Actually, that leads us to our next question, David, which is, how do you see the field of data science evolving in the next 5 to 10 years? And I think Robert puts a fine point on the fact that we're not educating enough people. So how do we address that gap, I guess? And then how do we evolve from there? Where do you see that going?
You know, it's interesting because I teach actively at 3 universities right now, and we're doing advanced analytics in those classes. And because it's evolving so quickly, I created a new class for SUNY, for example, this semester. And already for the same class next semester, we're totally redoing it. Now, by the way, Bob and I's our new book is going to be the textbook for that class, because this field is moving so incredibly rapidly. And back to one of Bob's talks about data and its importance. One of the things that I teach students in our classes, all right, you have data, all right, so you're happy, right? You throw a party. I have data. I can now start. But the question is, how good is your data? And do you have all the different fields in your data, all the different columns of information, all the features that we call it, that you need to really analyze that topic? And what I've started to do in my classes on advanced analytics is I will have the students use AI, learning, large language models, to actually critique the scope of the data, whether it has all the correct features, whether they're all included, and then which ones are missing. And then what I have them do on assignment after that is, all right, first of all, AI is going to tell you, what are you missing? Then you're going to do your own research and see if you could add to that. Because what's interesting is there's so many different public data sets that are out there, and a lot of them are incredibly lacking. But, back to your question again of where's this all going? Where's it going in 5 years? We think that, what Bob and I are doing right now with, no code, we clearly see that that's where it's going. There was, I think I would call it kind of like a slow start. There was something called, citizen data scientist back a few years ago, and everybody said, oh, wow, what's this? And this is something really cool. But the problem was there really wasn't a really good infrastructure for training these citizen data scientists on what data science actually is and how to do that without coding. So clearly, where's it all going? Bob and I are big disciples on, we believe that if you want to get everybody involved, you need to go no code. And then where's it going to go after that? We're going to have what Bob and I are already seeing and experimenting with, is having AI help us with our analysis, with our, and giving us more insights. We're going to come up with our own predictive models, but we're going to have AI also tell us, hey, we're going to ask it, can you do better than what the result that we came up with? So we see a more augmented picture of us working together with AI to try to create the best predictive models.
So, David, it's fascinating to sort of hear about the use of these predictive models in the data science, and I'm really glad you brought up the topic of the fantastic workshop that you have done. And I think both Deepu and myself have attended some of the sessions. It's excellent, I must say, to all our viewers. And I will go on to Bob with the next question, and he can even tell us a little more about the workshop that both of you conduct. But Bob, my question is, in this era of artificial intelligence, where do you see the place of large language models, the benefits of using an LLM in the field of data science? Bob.
Okay. I think it will be a big help, as David said, but we're so new into the game. What I'm also seeing is errors. So I'm going to put, again, a plug to say you have to have intermediate knowledge about data science to critique the large language models, to know when it makes a mistake, okay? A year from now, 2 years from now, it's conceivable it won't be making mistakes. If it, we can fine tune these models, we can do all kinds of things to make them smarter. But right now, what the message I would give people is they're not perfect. And in having a background in data science allows you to say it made a mistake. Let me give you another silly example is Kaggle is a data competition group that has like 100,000 data sets. Well, I saw one I've never seen before, so I downloaded and immediately uploaded it to, it was GPT-4 or one of the its offspring, so to speak. And I immediately asked it to summarize the data, and it said the average systolic blood pressure was 70,000. And I went, whoa. So to make a long story short, of course, I then looked at the spreadsheet and realized all the columns were in one column. So what is my point? You always want to start by visualizing, looking at the spreadsheet before you would trust a large language model to analyze your data. So there are some basic points, and that would be one, never start using AI before you personally have spent a lot of time looking at that initial CSV or Excel file to know exactly what's. Another example, sometimes missing data is blank, sometimes missing data is a zero, sometimes it's NaN, not a number, and then recently it was a question mark, and AI won't tell you that. So the point is, despite how good AI is in its future, its potential, you got to start with the basics.
Right. I love that, because the human eye is still needed in this, I think, and I think that's a great point. So benefits are great. So David, when would you recommend using an LLM, and when would you not? Bob just gave us an example of how we can make mistakes or hallucinate. In this case, I don't even know if that's a hallucination, it's just an error. But when would you recommend using them, and when would you not?
Yeah, well, if you look at, for example, the courses, the workshop that Bob and I have held for the past year and a half, and also the new certification classes we're starting in January, right away, if you're analyzing tabular data, you want to use large language models to critique your data. Is something missing? And also let it critique it whether you have some imbalances. Am I looking at an Alzheimer's study that only has white people, and it's totally devoid of any other ethnic groups? And let it help you critique. So what we, first of all, even in the tabular data part of the analysis, we want to use AI as a devil's advocate, to be on our shoulder, to have a look at what we're doing and seeing, and make sure that it catches any blind spots that maybe we don't catch. And then so we would use that type of AI as large language models as a devil's advocate for tabular data analysis, text analysis, also image analysis. And then when you get into the whole topic of trying to do problem solving, innovation on demand, there we lean on these large language models very heavily. Like, I don't know how many of you or your viewers are familiar with TRIZ, T-R-I-Z. It's the science of inventive problem solving. I was, came from an engineering background and used that very heavily in the past. And what I'm doing right now is the entire top people in the world of innovation on demand are now testing exactly how good are large language models in creating innovation on demand with the backgrounds and the prompts of understanding some of the techniques and how fast are they and how good are they. And what we're finding is some good friends of mine that I've been working with on that topic for many years is they're finding that large language models, if you give them the correct prompts in advance for basic problem solving and for coming up with inventive problem solving, that they can be just as productive within literally seconds of compared to innovation on demand specialists that have been trained and certified over a 6 and 9 month period. So we're very excited about that. I actually have some private competitions with the best innovation on demand people in the world right now to see if we could improve on that, because this is always improving. And it all gets back to prompt engineering. So in other words, how are you talking to your AI bots to have it help you better, as best as it possibly can? So, Bob and I are experimenting with that a lot, and we're incorporating that more into our classes. So back to your answer, yeah, it has, how can AI and large language models incorporate into analysis? From anything and everything from the beginning of being a devil's advocate, a guide, making sure you didn't miss something. And then when you're getting into the actual innovation on demand things, it's going to take the lead role where that you're going to come up with some ideas yourself, but you're going to see what it's going to come up with. And in the world of brainstorming, they say there's no such thing as a bad idea. People that are involved in brainstorming, that you involve in them, they hallucinate all the time. And nobody complains about it. There's actually books written about it that say, oh, we love to have bad ideas. But then when a large language model goofs up and makes one mistake, we want to throw it out of the window, But what about all the endless hallucinations that I've dealt with in the world of engineering and Lean Six Sigma and brainstorming, the worthlessness? But we're not allowed to critique that because every idea is a good idea in all the books on brainstorming. So we have to have once in a while a little bit of leniency that, okay, you're gonna get some hallucinations once in a while from AI. And that's why you have subject matter experts to filter that out. So you just don't take everything that a large language model is going to tell you and take it to the bank. You have to check it, just like you would check everybody else's idea who's going to, partially and full-time hallucinate during a brainstorming session.
I mean, that is a fantastic vision there, David, and it's really very insightful just to learn the fact that, an individual can kind of find applications in data science even without knowing coding. But having said that, it's very important to be a little literate, something which Bob just said in the beginning of the session, that you need to have a basic idea about what data science is. So a little bit of AI literacy before you start using the large language model is very, very important. That would be a message I would like to give it back to our viewers. But then again, it should take away your inertia about doing your own data analysis using the help of the large language models that is available out there. But that again brings us to another context, and I would like Bob to kind of come into this, is that in the beginning, you also said that there's a big inertia of data sharing because of the HIPAA compliance. So from the point of using these open source large language models versus the proprietorship ones, I mean, where do you see these ethical concerns are when you're using an LLM to do a data science work, and how do you see it going, Bob?
Well, that raises one other kind of issue, and that is synthetic data, meaning
Yes.
The synthetic data we generate now, by the way, is excellent. I mean, I have to say that it is amazingly statistically similar to the original data. You know what the barrier has been to me, in my opinion, in my experience, is people aren't ready for it. Once again, academia is behind the industry. As an example, I wanted to get some of Duke University's catheterization data. They had already altered all the dates and numbers and stuff for education, but I said, fine, I want to increase the size of your database and use it for teaching. Took them 3 months to finally go, oh, okay. And then I checked with 3 other universities to see if they had a synthetic data policy. The answer is none of them had. And so once again, academia is out there going, uh-oh, I guess we'll have to deal with it sometime, but maybe not today. But I do think that the nice thing about synthetic data is you will get around the whole issue of HIPAA and data sharing. Now, Anthony Chang would say, if you all went to federated learning and you shared the model and not the data, that would also get around it. But it's been very disturbing to me to watch the high-tech era come in, where we thought that every electronic health record would share with every other electronic health record in the country. That never happened. So data sharing.
Sorry, I don't mean to interrupt, but can you tell our viewers, those who may not know, what synthetic data is?
Sure. Synthetic data is, and let me just be specific, is if you're using artificial intelligence, you're probably using something called generative adversarial networks, or GANs, and it'll take your data set. Let's say you have 100 patients. This is good data, but you know that's not enough patients. It'll go in and memorize the patterns. In other words, between, let's just say, those with heart disease, your cholesterol level, your gender, your age, your ethnicity. It'll look at all those patterns, and then it will copy those patterns, not exactly, but then create 1,000 patients or 50,000 patients. But when you go back and do statistical tests, they're extremely similar. So if you have 14% of women in the original data set, you'll probably have 14% in that much larger data set. So there are probably 10 companies right now that are generating synthetic data. And again, I think it has a great future. There's one thing that came up a week ago. University of Florida has been able to clone their whole huge, I think, 2 million patients into a synthetic database that they're going to release open source for research and education. So stay tuned. In other words, once academia can approve it and feels comfortable with synthetic data, I think it's going to be a major player.
That's amazing. Yeah, thank you for that explanation, because I do think we have probably quite a few novices. I include myself in that, and so it's really helpful to have the context of synthetic. And I agree with you. I think we're going to see more and more trials. Like, you know, we currently see randomized control trials as the peak and the kind of the truth of evidence-based medicine and data, but I think synthetic data is really going to play a big role in it. So I don't want to belabor the point, but I think you've mentioned Notable a little bit earlier, and I wanted for us to kind of highlight a couple of things that you and David use pretty frequently. So tell us what Notable is, and what are some of the ways you've used it, or some of the common ways that it's used, and where it's kind of going.
Sure. And let me say again, I have no financial interest in any software, any hardware, anything. So my job, though, is to be that explorer out in the front, finding things that are valuable for other people. So it's like discovering a really rare shell on the beach, let's say. Notable is 2 components. One is just a plain programming notebook, like Jupyter Notebook or whatever. However, even that's different because it includes automatic visualization, which most notebooks will not do. So that's one thing. The other thing is that it connects, it has its own ChatGPT plugin. So first of all, you could learn to code, you could learn Python by asking the chat, how do you do something? Then you look at the Python and you go back and forth. When I learned a little bit of Python, I was super frustrated. I had no tutor. I had nobody looking over my shoulder to say, you missed a semicolon. So here, let's just take two components here. One would be you're an early programmer. You do want to learn Python. I would say the way to do it is to go back and forth between the notebook, write some code, and then you can ask ChatGPT, the Notable plugin, analyze my code, let me know where I went wrong. In fact, every once in a while, you have programming errors in ChatGPT, by the way. And what's interesting and notable is you can see the error in the notebook, copy and paste it back into the chat, and it'll fix the error. At least it has for me so far, which is really cool.
That's cool.
So that's the programming aspect. The more practical aspect is, what if you want to analyze data, but you're not interested in Python code whatsoever? Well, you can then say, analyze and discuss. Then you can say, create a classification model and tell me every step that you took and why you chose to do this kind of imputation, why you did this, why you did that. And so now you got paragraphs of explanation and no code. So I do think that's something that people need to understand. And getting back to David's point, the prompts are really important. And I think the better prompts that I see are longer. They have more data. It really gives the large language model a whole lot more ammunition to give a background. You know, you can say, I'm a faculty member teaching data science to high schoolers or whatever, but the more information you give it up front, the better results you're going to get. But getting back to Notable, it's a notebook, but it's also a ChatGPT plugin, and the two work in harmony.
Mm-hmm.
Yeah. So for all our viewers out there, I mean, if you are really feeling, just hold on to your horses. I mean, I'm really sure that, if you get into these workshops that David and Robert does, you would be getting more insights into these specific use cases, like, for example, notable that he just mentioned. And also, there is a fantastic use case of Orange, and I'm sure they're going to tell us about that a little later. But before that, David, I want to come up to you with a very simple, practical question. I think that would be in the mind of all our viewers watching today, as to where does one start from if you're a doctor or a clinician and you need to start having clean data analyzed. Where do you start from if you need to do it on your own? Your thoughts, David?
So if they have to do the analysis on their own?
Yeah.
Yeah, I
Yeah.
mean, doing it
So-
on their own as a starter. Yeah.
Yeah, so yeah, we've had situations like that where doctors will get a hold of Bob, doctors that I know will get a hold of me, and these are people that are expanding their practice, and they're saying, "Oh my gosh, we don't know how to analyze anything. What are we going to do? We're growing like crazy." Bob, I'll mention just the word cardiologist. You know who I'm talking about, and a cardiologist group that's expanding dramatically throughout the country, but they don't have data analytics. And they know that, they want to sleep better at night. They want to feel better about their decisions. They want to have somebody looking over their shoulder, giving them some opinions, which AI can do. So where do they get started? Back to your question. Oh my gosh. So where do I start? Do I dust off my statistics book and look at, multiple regression again, or what do I do? Now, so let me give you a little background on that. So, because if anybody's been trained as far as, medical students, they've been trained maybe in statistics. They haven't been trained in machine learning yet. And what you need to understand about traditional statistics is it's like looking in the rear view mirror. Mm-hmm. It's looking at where you've been, where your data is gone, and what it looks like. But what predictive analytics, machine learning, and AI is, we have this huge windshield in front of us. We're trying to see where we're going. Now, does that mean that predictive analytics and AI are going to totally, do away with traditional statistics? No, they work together in tandem. So again, back to your question, where did they start? Well, brush up your old statistics, dust off your old statistics books, and when you look at those and you get frustrated and say, oh my gosh, I need help, then what you need to do then is find a place where you're going to get some help. And what Bob and I advocate for is forget coding. Who has the time to learn coding if you have a full-time profession? And there are those people that love coding and can pick it up. Whenever I speak at a Lean Six Sigma conference, one of the first questions I ask is to say, please raise your hand if you're a coder. And it's always strange. There's 3 or 4 people in the back row that raise their hand. Nobody else raises their hand. So, 2 to 3% of the people are coders and feel comfortable with that. So again, what do these people do? You have to start to learn the data science and learn the data science, and then the methods that Bob and I have been using of how do you teach that, how do you use it with no code, but you need to understand the science. And we'll probably get into it a little bit later, but I don't want us to forget it. And Bob and I are adding in another incredible layer of excitement on our new classes, where we're teaching most of our stuff right out of the Kaggle competitions. And we're creating our own competitions where that students with invitation only can go learn on. And then when they learn a few things, we could then go outside that box once you know how Kaggle works and say, hey, let's look at a Kaggle competition. I mean, after all, they do offer prizes once in a while up to $1 million for the best predictive models. So that should, generally attract and interest, the general person on the street of, wow, people are actually paying me money, can pay me money to learn a model. Now, here's one thing I also want to add is anybody can make a predictive model. Anybody. Just go on Kaggle, you see millions of them. But how many of them are useful? Not many of them are useful. And that's why, Bob and I try to ground people in what is the data science behind predictive analytics to make sure that you're not in the 95% that are going to create useless predictive models, but you're going to be in the cream of what we call high performance, no code predictive analysts. They're going to actually be able to create high performance predictive models and be ahead of the group. So again, to recap the answer to your question, you have to retrain, you have to upskill. And the best way to do that is with methods that teach you the science without the coding. That'll be the least painful route to head in that direction. So I hope that answered your question.
Yeah, actually, that segues wonderfully into the next question, which is, what are no-code tools, Bob? David mentioned it, that we don't have time to learn coding or another language. We spent our entire careers learning medical language and the lingo. I don't have time, but I do want to do better for my patients and for my company and for my community. And so, what are no-code tools, and how can we leverage them as clinicians?
Sure. And before I talk about the 2 tools that we use, let me just sort of say that in a general approach to this, we would love to have more clinicians data literate. That's step number 1, meaning they're comfortable looking at missing data and knowing what to do with it. They can do some basic statistics like a t-test. They can visualize data. They can do a box plot or a histogram. That's basic data literacy. So once they're good at that, they move on to creating models in machine learning, which is predictive analytics, basically classification, regression. Once that's mastered, the next logical step is AI. So that's not written in stone, but I'm just giving you a little orientation of how I would approach that. Now, that being said, honestly, I spent the last probably 6 years looking for tools. I use Weka, W-E-K-I-A, out of New Zealand, but it was not well organized, was not intuitive. Then I ran into Orange data mining. I don't like the name Orange, but that's the way it is, out of Slovenia. It was created by 2 computational biologists. And so people listening in understand, you don't use Python, but that's what's working in the background. When you connect a file widget that has your data in it to a box plot widget and you connect it, you automatically have box plots created. In the background, there's some Python code doing its thing, but you never see it. You never have to worry about it. So the whole idea is you connect widgets to other widgets, and that executes whatever function is you're trying to execute. So Orange can do tons of things. It can do all your visualization, your basic descriptive stuff. It can do, again, modeling, regression, classification. It can do image analysis. There's 6 convolutional neural networks in Orange that you can use to analyze images. Text mining, it does a ton of things. It doesn't have its own large language model, but so it does a lot. And so the second program we use, which is also free and open source, is JASP out of the University of Amsterdam. Under the hood, it uses R because it's statistics, right? So we supplement. There are a few things that Orange doesn't do in the descriptive statistics world. And so JASP will do those. But JASP also does machine learning, both supervised and unsupervised learning. So it by itself is a pretty good data science platform. It doesn't do image analysis. It doesn't do text, but it's a great, easy, super intuitive stats program with a great user guide, all again free, and Orange and JASP both update all the time. So they're not static programs. They keep releasing new updates and improvements. But both, again, we use as the background for data science because that's how we evaluate data with those 2 tools. I'll stop with that.
Yeah, I think that was really insightful. And to most of our viewers, we really need to get into Bob's website. I think we're going to post that in the message section if you're watching this from the app. And if you're watching this from our recorded videos, we will be finding that in the comment section as well. And the workshops, I must say, are fantastic. They're very insightful, and you would probably get very real life use cases that you can sort of use and apply into your clinical practice. So David, I'm going to come back to you. In the beginning of the session, somewhere in between, both of you mentioned about Kaggle competitions. Could you tell us a little more about it? And I mean, understanding that it's an open source or a side platform, could you tell us about, the benefits or the limitations that we get out of it and how you're using Orange in the Kaggle platform? Your thoughts, David?
Yeah, Kaggle is very exciting. And why do I say that? Well, like I said, there's competitions out there that will pay up to $1 million. These are large companies. They'll say, can you beat the best predictive model that our data science team has created? So that in itself is pretty exciting. There's a lot of smaller competitions and along the way. But the interesting part of Kaggle is whatever you do, whatever competition you join, by the way, they're all free, that you join, it's kind of like, you might think, hey, I'm pretty good at this. But in reality, every one of us are nothing but a big fish in a small pond. And if you look at Kaggle and you say, oh, I'm pretty good. Okay. They say, what have you tried a few Kaggle competitions and see how you appear on the leaderboard? And when people do, they say, oh my gosh, okay, yeah. So it really doesn't look as good as I thought. So the beauty of Kaggle is multiple fold. But if you think that you're up here and you go in the Kaggle competition and find out you're over here, that is absolutely great because you're going to say, all right, what am I missing? What can I learn? And from these Kaggle competitions, the people that are the leaders on the leaderboard, they actually share some tips. And Bob and I are in the process of creating all kinds of, competitions also, but again, by invitation only for people that are going to be in our workshops and our certification classes. And we will teach them to learn as a team, not that they are intimidated by saying, oh my gosh, I'm pretty low on the leaderboard. But in our classes, we will then brainstorm with the team and share and say, all right, Joe, how did you get up? How did you get up to first place? Or Mary, what did you get up to second place? What did you do? So that the class will learn. And we learn that as we want to use that as a learning platform. It's gamified because you have this leaderboard. We have it set up where that you're allowed to put in 10 new predictions every day. It's not like you put in one prediction, you say, oh my gosh, I'm embarrassed, I want to take my name off the list here. No, you can put in 10 predictions a day, and it'll always update your position on the leaderboard based on your best prediction. So we look at that, and we got some very unique ways for how we want to use that for a lot of interactive training. There's a lot of people that, they want to learn data science, but they also have in the corner of their mind, they're kind of like a thrill seeker, and these thrill seekers are people that seek a little bit of excitement. They could get that from these Kaggle competitions. You could learn from us in our specific, invitation only competitions, and then what you learn there, we encourage, okay, let's kind of do like a field trip outside of our private group. Let's go into a competition and let's see how our best models look. And then we come back into our private learning area. We say, okay, now what do we learn from that? How are we going to improve, team? What are we going to do? So we see Kaggle is an incredible learning opportunity. Shows you visibility, how good you are in certain areas. It has every type of data set you could possibly dream of, from image analysis to text analysis to tabular. So it's just a very exciting platform to use for our learning for our students, and we're gonna probably switch to that almost 100%. As far as when a student is doing a project, do it at 100% in Kaggle.
That's amazing.
And Dave, if I could interject one thing. Interestingly enough, 99.99% of Kaggle is coding. We're going to be the first in there to do Kaggle competitions with no coding, because basically all you have to manufacture is the end test result. First column is ID, you know which patient it is. The second column is the outcome. So you've already uploaded the truth, what we know to be the truth. And so with this file, the student would upload, you're matching your best bet to the actual truth. And that's all it is, 2 columns and a CSV file. So it's really simple, but we're doing it again without coding. And that's what makes it truly unique. So
I actually think, go ahead, David, sorry.
And one more thing is, a lot of people might say to themselves, is no coding a compromise? Am I really going to be as good as a coder? Well, that's where all of this, working with Kaggle competitions can make you feel better about yourself and say, wow, I'm actually better than a huge percent of coders in this one competition. And you can see that, this is not some kind of a cheap shortcut. This is, we're using Python in the background, like Bob mentioned. So this is the real deal.
Yeah, so I actually think you've kind of answered my next question, both of you. You've kind of skirted it, which is, how can code assistance tools help data scientists and I guess clinicians be more productive in their daily lives? And you've mentioned a couple of perks, but are there specific examples that you have used or implemented with people, and how that's impacted their workflow and your workflow, I guess?
Well, I'll start here, and Bob can pick up on it. We don't really consult or advise anybody on coding themselves. We use the no-code approach, right. And typically, clinicians, at least a lot of the ones that we deal with, they have trouble understanding, statistics and machine learning, and some of them, again, a small percent, are going to use coding and want any kind of assistance from that. And the large language models here and there are going to help you to correct some of your coding. But again, we're there to try to help people to get the solutions without the code. Bob, you want to chime in?
Well, I don't have too much to add to that. I mean, I think that if you're looking for real world examples, again, you could even start with spreadsheets, making sure that the average clinician knows how to maximize a spreadsheet. You can also educate them a little bit about even the large language models. I think its strength, by the way, is just you upload a data set that you've already gone over, the Excel file, let's say, the data is what it is. and you can simply say analyze and summarize. It's an okay starting point, but then you need to do some more serious things. But I think that's one of the things that I don't think I've seen many mistakes, is if you ask a large language model like Notable or whichever one you use, analyze and summarize, which means they'll give you descriptive statistics and they'll summarize the columns and the rows and stuff. It's not a bad starting place, but you need to go further. And that's where Orange and JAS come in handy.
So I think this discussion has been really fascinating. I mean, we started with understanding why data science. In fact, when I was kind of telling my peer groups about this podcast, I had a lot of questions that why are we even talking about data science amongst clinicians? So by now it's clear that data literacy is very important. If you want to be AI literate, that's a very important thing that we need to do. And a fantastic effort has been put there by Bob and David in with their workshop, where they're actually educating so many clinicians as well as data scientists across the globe on this basics of data literacy. Kaggle competitions, I think it's going to be something that would really excite most of the data scientists working out there. I'm sure many of our viewers would also be today who are working with data in a professional way, as much as it excites David and Bob. So we are almost to the end of our session. We had a fascinating 50 minutes of discussion. But before we take up some questions coming up from the audience through Harshita, I would really like to ask Bob to kind of give us an overview about the workshop that you're doing, so that, if any of our viewers are interested to join in, how they can go about with it. How is the curriculum like and the certification?
Okay, well, I'm going to have to say at the beginning that the workshops are going to come to a close this month. This will be we have been doing free monthly workshops now for roughly 2 years. We did a series in Australia, I might add. But we decided that we would then convert to a certification course instead. And that starts in January. So the workshop that we've done will end this month. And David, you want to just say a little bit more about the certification course that we anticipate in January?
Yeah, we have 3 levels. The first level is going to be about fundamentals, and you'll learn all the fundamentals about no-code data science. We'll cover everything from tabular data to text analysis, LLMs, a little bit of prompt engineering, and then obviously image analysis. But it won't be like you're not really doing projects. Now, what we call the level 2 certification, you're going to be doing projects, and you're going to be in our private competitions on Kaggle. You're going to be looking, and we're going to be you're going to be doing 2 projects in each of the 4 different sections that we're going to cover. And then we have what we call level 3 certification, which is really the advanced practitioner. So the level 2 is a practitioner. You're actually doing things. You're knowing how to solve problems. We're way beyond theory. We're not just talking about theory anymore. And, can I go in a restaurant and a bar and chit chat about AI, or can you actually do it? No, we're actually on level 2. You're doing machine learning. You're doing AI. You're going to be able to build up a portfolio of projects. You're going to be able to point to your leaderboard position on Kaggle here and there, potentially, to say how good you are. And then, so like I said, level 2 and level 3 will get you into a higher level and a higher number of projects. And because we're dealing with the Kaggle platform, we're introducing all of our students to what we refer to as high performance, no code predictive analytics, because we're going way beyond just, okay, I could do a model. We're doing good models, but we're going to teach people how to be very competitive and actually be proud of something that you might actually submit in a Kaggle competition where you have the best coders and analysts of the world that are competing, and you can compare your skills against them.
That's great. And that sounds very exciting, actually. I would love to take that course. I think we're about to wrap up, but I do want to hand it over to Harshita for questions from our audience.
Yeah, so we have received questions from our audience, and here's the first one. how to choose, train, and deploy a scientific AI-driven algorithm to meet the needs of the organization.
All right, I think Bob can take that.
Yeah.
Do I have an hour to answer that?
Yeah. Whole other podcast, right?
Yeah. No, I mean, there's not going to be any simple answer to that, but there
Yes.
are basic steps. The first step, though, is sort of a reality check. Do you have the data to support this project? Do you have buy-in by whoever's organizing your hospital? In the United States, we call that the C-suite. You have buy-in by them? Do you have buy-in by your medical staff and your nursing staff? Or is this going to be a royal pain? In other words, it's got to make good sense. It's got to make sense to your patient population. So the starting point is a reality check, and the medical staff is very important there because they should give it a thumbs up or a thumbs down. They should also do the lit search, the literature search, to say, hey, this has already been done, or it's been tried and it was unsuccessful. So the medical staff can be very important, but that very first step is designing a specific narrow project, not a shotgun. It needs to be a rifle. In other words, your goals should be very attainable and very specific with good buy-in. And so that, I hope that answers it, but to me, that is the starting point when you say, I want to get into an AI project for my hospital.
David, you want to add something?
No, I think Bob pretty much covered it all.
Right.
All right, Harshita, do we have any more questions?
Yeah, so other questions that have been already covered in the discussions. So thank you
So
all.
Harshita, before we end, I would just like Bob and David to give quick take-home message for our viewers, which would be mostly clinicians. I'm sure a few intrigued data scientists would be watching this, some researchers. What are your messages for them, Bob and David, in the era of data science and AI?
Okay, well, number one, don't be afraid of it. Number two, get your hands dirty with data, meaning you need to practice with data. Start with a spreadsheet, of course. Keep in mind that Microsoft Copilot is going to embed AI in the Excel spreadsheet. Lord only knows what that's going to do. That may be your savior. You may ask it questions and you skip a few steps. So, but it's a brave new world out there. I mean, AI is here. It's not going anyplace. Be bold. Learn as much as you can. Dave?
Yeah, one thing I could add to that is, what we're going to teach people is how to be an experimenter. And if you want to win a Kaggle competition, you want to solve you want to cure a disease, you want to come up with a new discovery. It's all about coming up with an incredibly new insight. And if you look at, for example, all the algorithms that we could even deal with in Orange, there's about 9 or 10 if it's regression, 9 or 10 if it's classification, but there's about 80 derivatives of those options. And then if you look at what are referred to as hyperparameter optimization options on top of that, there's millions of them. So in other words, there's millions of opportunities to try to find the best model. And what we do in our classes is make sure that we teach people how to be experimenters. So clinicians, scientists, researchers, and in the world of Lean Six Sigma, we call that design of experiments. There's a statistical method out there to actually teach people to be experimenters. And what's fascinating is you find that in the world and the studies of data science, they don't teach design of experiments. Well, guess what? Bob and I do. Because if you have millions of options, if you're not an experimenter or don't know how to experiment, you're not going to get to your best solution.
That was very, very insightful. Thank you both. This was a wonderful episode. I really enjoyed this conversation. I guess the message to all of our listeners and viewers is go out and tinker and don't be afraid to tinker.
Yep.
So thank you so much for joining us for another episode of Decoding AI in Healthcare. And we'll be posting this for your viewing in the next 24 hours. Thank you.
Harshita?
Yeah, thank you all for sharing your insights. Your perspectives have been enlightening, and we hope to have you back soon.
Thank you.
And now a quick announcement before we wrap up. Our next episode, scheduled for the 18th of December, will delve into the fascinating realm of AI in diabetes, endocrinology, and digital twin. Don't miss it. See you all there. Until then, stay curious and stay informed. Bye-bye.